Hello students, welcome back. Previously we went through the definition of the composite functions and then did some elementary exercises. And I hope everybody remembers this picture. It turns out the domain of the composite function is smaller than the domain of g, the inside function in general. It is contained in there. And also, by the same reason, the range of the composite function is smaller than the range of the outside function. Here is a good visualization. Start from x and then come to y via g, and from this y we get to z via f. That's f composition g. So g first and then f, and get all the x values that can come from here, y and then z, that's the domain, and then get all the z values that's coming like that is the range. And as you can see, the range of composite function is smaller than the range of the outside function, and the domain of the composite function is smaller than the domain of the inside function in general. Sometimes they are same, sometimes one is significantly smaller than the other. Okay, how about this? Determine the domain of the given composite function. Okay, all right. So the domain of g, well, you don't really have to worry about anything here. In this case, it's just too simple. Just calculate this composite function, then we get just polynomial. Any x will do. So negative infinity to positive infinity, anything will do. That one was actually duh, but here we're going to get something interesting here because we have fractions. So whenever denominator hits 0, things can go bad. So expect something going bad. Do your computation and then set the denominator equal to 0. What do you have? X is not equal to -1. So domain is negative infinity to -1 to -1 to infinity. Does it match the graph? And looks like it does. X equal to -1. Vertical asymptote there, otherwise all fine. But why in the world did I label it as incomplete solution? What's wrong here? Anybody found out? Here, I just went directly to the algebraic expression of f composition g and then find out the domain of that function. Go back to this picture. The domain of composite function is gonna be contained in the domain of g. So even we get x to z, if it doesn't come via g and then f, if there's any other paths going directly, then that's not the composite function. So we have to consider domain of g first. Here we go. First, the domain of g. And it's easy. X is not equal to 1. Denominator should not be equal to 0, so that's 1. And then we can consider the composite function computation, and from here we get x is not equal to -1. This denominator should not be equal to 0. So we have to exclude x equal to -1, but also we have to exclude this one as well. X is equal to 1. So get those out, both of them out. You're gonna get this. Compare this and that. A bit of a difference there. From the number line, we excluded one number. Here, from the number line, we excluded 2 numbers. Here's better graph. We have vertical asymptote here, but here we have a hole. If you just rely upon technology, the graph will not find this. Actually, there's a hole at x equals to 1. That's where the function g is not defined, but if you look at the algebraic expression of this, it is well defined. So when x equals to 1, g of x is not well defined, so g of 1 is not well defined, but still, f circle g of x, that algebraic expression is valid. So one is going directly from x value to z value, bypassing the function g. So this kind of thing can happen here. It's tricky, and it's rather a mean problem. Therefore, I have to admit I do not really emphasize it in exams or anything significant, but in homework I do. Yeah, you'll have to do some of these in homeworks, especially in my MATLAB homeworks. Okay, we went through a trivial problem and then a bit tricky problem. So all right, we have 3 more. Can you do those on your own? At least try. Okay, how about problem C? Let's find out the domain of f circle G. Now, in the previous problem here, let's go to the complete solution. We did the inside function first, and then we went through the composite function and worked out. Why do you do it this way? If you do it this way first, this one first, the second step first, then you may get exhausted here because this takes a long time, and then you may forget about this. That happens. So whenever you have a simple step and complicated step, usually the best way is to get it done with the simple step first and then go with complicated step, because you may end up forgetting that simple step later on. So domain of the inside function first, and that's easy. Denominator should not be equal to 0, so x is not equal to -2. Easy. And then let's work out the composite function. All right, composite function, all right. G of f of x, so g of 1 of x plus 2, and simplify. Okay, we get that expression. Therefore, x is not equal to -1. Put them together. What do we have? I have to remove x equal to -1, but also I have to remove x equal to -2 as well. So doing this in step 1 helps you remembering this step. If you do this one first, after all this, you may forget this. Anyway, put everything together. We have to remove 2 numbers, and here's the graph. We have a vertical asymptote at x equal to -1, but at x equal to -2, we have a hole. Please note that we have a hole at 0, y-coordinate value is 0. It's not a coincidence, actually. Let's see, we have another problem here. Okay, all right, this is going to be a little bit more challenging. We have domain problem and we have radicals here, so it's going to be a little bit more challenging. The inside of the radical is greater than or equal to 0. So how do you work? Try it first. Did you all try? Okay, let's go. So inside first. Inside function, graph first. Yeah. It's usually better to have graph of everything. So okay, all right. Take the graph first. G of f of x. I take it back. I was able to graph this rather easily because I'm using computer algebra system. If you're using Desmos graphing calculator, if you do not calculate this composite function, it's going to be very difficult to deal with graphs. So okay, graphs really help, but let's pretend you don't see the graph. Okay, domain of the inside function. Inside of this square root has to be greater than or equal to 0. So there you go, -1/2 to 0. Make sense? Okay, So the domain of my function must be contained here. Okay, let's get the algebraic expression of the composite function. And okay, I'll assume everybody did this in the previous set. These right here. I left those two problems to students, and I assume everybody did it already. Okay. Here, we already took care of this algebraic part, the radical part. So we have to set the denominator equal to 0 and work out. It's a radical equation, and you probably recognize what this radical equation is because we've done this already in 11a. Anyway, okay, go ahead and then square both sides and solve it. You're going to get x is equal to 0 or x equals to 3/2. So we have to exclude them, but be careful here. Maybe not both of them because some of them may be extraneous. Plug in x equal to 0, it turns out denominator is not 0. So that's extraneous. Plug in x equal to 3/2, denominator is indeed 0, so that's a legitimate solution. So this is unnecessary. This one is necessary. So from here, I had to take out 3/2 out. And that's the domain. Does it match the graph? Well, it will. The graphing is left to the students. Let's see. Right here, at 1.5, we have vertical asymptotes, so that's out. And I'm starting from here, -1/2. As you can see, at x equal to 0, you don't see anything there because there's no problem there. So some domain problems are related to those domains of algebraic functions. Do you have enough time for the final problem here? Let's try. Again, I'll assume everybody went through this computation already. So let's go ahead. This algebraic expression, I'll assume everybody did it already. Okay, the domain of the inside function, the denominator should not be equal to 0. So the domain of g, we get this. X is not equal to -1, x is not equal to 2, otherwise okay, at least so far. Now take the composite function and we do computation like this. And then we have the inside of the square root should be greater than or equal to 0, so that'll give me a rational inequality. A rational inequality like this. Take the common denominator and work out. We have 2 zeros and 2 poles. They're going to divide the number line into 4 pieces. And then we have to select plus, plus, plus. Poles, they cannot be equal to 0, so they are expunged out. Zeros, yeah, they can be equal to 0 in the numerator, so they're okay. Putting everything together, from -infinity to -1, that plus region, and then from 0 to 1, that plus region, bracket, bracket, and 2 to infinity, this plus region. Does it match the graph? Well, here -infinity to blowing up to infinity, okay. That's bracket, bracket, blowing up to infinity to there. So yes, open, open, and we have bracket. Yes, everything matched. Nonetheless, this is a super hard problem. Okay, so much for this, and we have one more to go.